Hello guys, welcome back to my channel. In this video, we'll be talking about the Laplace transformation. We should prove that the Laplace transformation of sine AT, okay, is equal to a over s squared plus a squared, okay, provided that a is greater than, sorry, a is less than s, okay, or s is greater than a. Now, the first method of solving this is, I'm going to use two methods to solve that. And the first one I'm going to use is that we know that that the Laplace transformation of any function of t, okay, is equal to the integral from 0 to infinity of e raised to power minus st, then that function of t dt. If you know this, you will now know that the Laplace transformation of sine AT is equal to the integral from 0 to infinity of e raised to power minus st. Then this man will now be sine AT, then dt. Okay? Now, let me say, let this be equal to x. Let's say, let this be equal to x. Okay? So my x is equal to this. I want to integrate this. Okay, or don't worry. Let's leave it this way. Now let x be equal to the integral from 0 to infinity of e raised to power minus st sine at then dt. Now, if you look at this very well, you see that this is integration by parts because it is the product of two things, okay, two functions. Now, don't forget that integration by parts said that the integral of u dv is equal to what? uv minus the integral of v du, okay? If you remember that we choose u and then the other one becomes v, and we don't just choose u anyhow we like. We use what we call ladies like pets. Yes, like my wife, she likes pets. Yes, so every lady like pets. So if we know this, we know that if we have polynomial becomes our, sorry, logarithm. This is logarithm, polynomial, exponential, and trigonometry. So exponential came before trigonometry here. That means exponential is going to be my u, while the trigonometry is going to be the v. So that's what we're going to have here. So this implies that my u is equal to e raised to power minus st, okay, while my dv is equal to sine at. So from here, to get your du is just to differentiate. Differentiation of this is minus s e raised to power minus st. Okay? Now, to get my v is to integrate this. And the integral of this will give you, integration of sine is minus cos. So, minus cos at all over a. Okay? So, if you have known this, let us now substitute. We'll be needing a lot of space for this. So let us do a nice job here. So let us substitute. This is now the integral of my u is e raised to power minus st. Then my dv is now sine at dt. Okay, is equal to, what is my u? They say uv minus integral of v du. So uv, u and v should give us e raised to, okay, minus e raised to power minus st, then cos at all over a, then minus, now the integral of v du, v and du, right? We did u, v and du, which will give us minus here. We made this plus. So I'm having s over a, then e raised to power minus st, then cos at dt. Oh, sorry. This is not showing very well. Okay, so like I said before, we'll be needing a lot of space for that. So let me clean this place so that I'll write it very well. Okay. So we have the integral of e raised to power minus st, then sine at dt, is equal to uh, minus e raised to power minus st cos at over a. Okay, then I'm having here minus, now minus s over a is the constant I have here, so the integral of e raised to power minus st cos at dt. Now this is another integration by parts. Okay, so this is another integration by parts, so let us quickly do that. So this is the same thing as saying uh, minus e raised to power minus st cos at, okay, over a, then minus s over a. If you come to this place, we are going to say that this is u again and this is dv. So don't forget that integral of u dv is equal to uv minus integral of v du. Okay, so we open bracket to do that for this. So this is our u and this is our dv. So our u here is equal to e raised to power minus st, while our dv is equal to cos, lay this like that, okay, cos at. Okay, so uv, our u is e raised to power minus st. Our v here will now be integrating this to have sine at over a. So this is sine at over a minus the integral of v du. This is my v, which is what? Du is minus s e raised to power minus st. So I'm having minus s over a. So minus s over a, then e raised to power minus st. Then that is my v, then du. Okay, sine at dt. Okay, so now don't forget that this person, we call this person x. So if you say that this is our x, so if you call this person our x, then we see that we still have another x here. So here will be x. So this is going to be x is equal to minus e raised to power minus st cos at over a. Okay, then minus this, multiplying this, I'm going to have s over a squared e raised to power minus st sine at. Okay, this and this is going to give us plus, so I'm going to have plus s squared over a squared, right? I'm going to have this is going to be the integral of e raised to power minus st sine at dt. Okay, so, and you know that this person is s. So if this person is s can come here to have 2s. So where am I making mistake? Okay, no more. Let me go mistake here.